Hi, I'm Pat Kelly. Okay, so they want us to find a formula for a sub n for the arithmetic sequence. And that's all they give me to start with? Well, they also told me this, and you have to catch it in the directions, is that it's an arithmetic sequence. It's very significant. What that always means is you go from one term to the next, you're going to increment by some specific difference, that common difference that we usually label with a D with these problems. And so what I'm actually going to start with is to try to find that D, okay? So let's take the two terms that they did give us and find the value for that D in order to get the ball rolling here. And what I'll do first is, if you notice, just a little bit of arithmetic. I'm going to grab these two subscripts and just subtract them. 4 minus 1 equals 3. Okay, easy enough, but why? Why did we do that? This 3 tells me that that's how many increments you would have had to have made in order to get from this first guy to this second guy. And it doesn't matter what the subscripts are if you do this step, okay? Somewhat coincidental for me in this problem, one of mine is a sub 1, right? That doesn't matter. Whatever the two subscripts are, subtract them, and that'll always tell you how many increments to get from the earlier guy to the later guy. All right, so let's do that now with some algebra. What we just said verbally will look like this algebraically, is in order to get a sub 4, you'd start with a sub 1, or more generally, in order to get to your later guy, you're going to start with your earlier guy, and then plus 3 of the increments. And you want to catch that that 3 is this 3 that we just calculated, okay? All right, what that's going to allow us to do is to solve for that D, because we actually know what these two a sub whatevers are. So a sub 4 is 15. Let's substitute. Equals a sub 1, which is 5, plus 3D. Okay, good. One equation, one unknown. We can solve for that. So I'll throw the 5 over here. Subtraction, 10 equals 3D, so D equals 10/3. Nothing wrong with a fraction here. So that 10/3 is going to be my value for D. Now let's use that in order to find that most generic formula that we can, as generic as we can be for a sub n. We start with this, a sub n equals, and what will always be true here with these arithmetic sequences then is if you started at a sub 1 and you're trying to get to a sub n, you would have needed n minus 1 of those increments. So n minus 1 times d, okay? Now let's continue with this formula and put in some specifics. For instance, one of our specifics is that we do know what a sub 1 is. It's 5 for me. Plus, and I'm going to keep the n minus 1 generic because I don't know that yet. And my d is 10/3. Make sure it's clear that that's multiplication, right? I haven't done anything on the left-hand side. That's actually still just a sub n. Remember, our goal is to find a formula for a sub n. So I like that there. A sub n equals. And now a little bit of algebra. The 5 I'll leave alone, but the 10/3 I'll distribute through. 10/3 n minus 10/3. And we're only one step away. A sub n equals, and I'll combine these two like terms, the constants. So maybe a common denominator of 3. That'll make this 15/3. Take away 10/3 gives me 5/3. Plus the 10/3 n is still there. And that's what I wanted. A generic formula for a sub n. You tell me what n is, plug it in there, and I'll tell you what the a sub nth term is. Okay? Good work. I did some good work. I'm sure you were doing it with me. Now do some on your own too. All right?